students, welcome all of you. Today we'll start nuclei JEE level 1. Level 1 and level 5 we are going to discuss in this video. Okay, in this lecture. So total questions, then class work and then homework. Okay. First level and level 5 we are going to discuss in this lecture, and level 2 and level 6 in the next lecture. Now in the homework there are 16 questions. Total 16 questions are there, out of which I am going to solve 1, 2, 3 and 4. For you there are 12 questions. So you solve the 12 questions except the question I am going to mention here: 4, 8, 12, 15. 4, 8, 12 and 15. 16 क्वेश्चन यासाठी काय घेतला, ठीक आहे, थोडासा लॉजिकल थिंकिंगचा क्वेश्चन आहे, तुम्ही ट्राय करा, जमून जाईल. नाउ क्वेश्चन नंबर 4. Question number 4. A slow neutron strikes a nucleus of uranium 92. Uranium 92 238, and slow neutron strikes to it. Okay. Then splitting it into lighter nuclei of barium and krypton. Barium and krypton. Barium delight 56, 141, and krypton 36 and 92. The energy released in this reaction is. What is the energy released in this reaction? This is asked. Now, what are the things given? The masses of uranium. So, mass of uranium is given 235.043,933. Then units. Again, mass of barium is given, that is 140.917700. This is the mass of barium. Then mass of krypton is given 91.895400. The mass of neutron is also given. Mass of neutron, which is also given, is 1.008665 units. What is asked? The energy. Now see, we know the binding energy, which is nothing but mass defect into c square. This is in joules. And if you want the energy in electronic volt, we have to divide it by charge. Now, this delta mass is the mass of products minus mass of reactants. So, sum these two. This is the mass of product, and mass of uranium and neutron is the mass of reactant. So, delta M. Okay, so we can say mass of barium plus mass of krypton. This is the mass of reactants, minus mass of uranium plus mass of neutron. This is the mass of reactants. Products minus reactants is delta M into c square. Speed of light square. Speed of light square into 1.6 into 10 raised to power minus 90. So substitute all the values and solve. You will get the answer. Then we solve that. Okay, this will put a solve. So this is the logic behind this question. I just want to tell you the logic. Calculation is not a big deal. Calculation to be plus minus करायचं. ठीक है? C is the speed of light. This is question number 4. Now question number 8. The isotope uranium 92-238 decays successively to form. So याच्यामधून चार प्रोडक्ट बाहेर पडतात. आपण असं म्हणूया, फर्स्ट प्रोडक्ट, second product, third product. Different reactions are there. So in the first reaction, it produces thorium, atomic number 19, mass number 234. Then in the second, it will produce palladium, 91-234. In the third, it produces again uranium. Okay, total 5 reactions are there. Uranium 92-234. In the next, it produces thorium 90 and 230, and the last is produces radium 88 and 226. The radiations emitted in these 5 steps are, okay, असं आहे actually. Not different, successive म्हणजे पहिल्यांदा युरेनियम पासून हा पडला, याच्यापासून हा पडला, याच्यापासून हा पडला, याच्यापासून हा, याच्यापासून हा. Okay, now see here 238 चा 234 झालेला आहे आणि 92 चा 90 झालेला आहे. म्हणजे atomic number reduces by 2 and mass number reduces by 4. That means it is the subtraction of alpha particle, that is helium-24. So 90 plus 2, 92, 234 plus 4, 238. So the first particle emitted is alpha particle. Now we have 90, 234. आता 234 remains 234. 90 चा 90 मध्ये झाला. That means here the emission of this minus alpha will write here, minus alpha particle, that is 2He4. Now from this here to here, see, minus beta particle, that is electron minus 1 0. That's why 91 minus 1 is 90 and 234 plus 0 is 234. That means second particle emitted is beta. Next, third step, इथं 91 आहे, इथं 92 आहे, इथं 234 आहे, इथं 234 आहे. That means again the emission of beta particle, that is minus 1 electron. So see, 92 minus 1 is 91, 234 plus 0 is 234. So again it emits beta particle. Then the next step, 92 becomes 90, 234 becomes 230. That means atomic number reduces by 2, mass number reduces by 4. That means it is the emission of alpha particle, that is 2 helium-4. So again the alpha particle. After this, in the last step, this 90 becomes 88 and 234 becomes 226. That means atomic number reduces by 2 and mass number reduces by 4. Again the emission of alpha particle, that is 2 helium-4. So alpha. So your answer will be alpha, beta, beta, alpha, alpha. So which option is correct? Option number C for Chennai. C is correct. So this solves question number 8. Okay. Nice question. Now question number 12. Question number 12. The radioactive carbon 14 in a wood sample decays with half-life of 5700. So T half is 5700 years. Okay. The fraction of the radioactive carbon that remains after a decay period of 17,100. So after t is equal to 17,100 years, what is n? This is asked. So we know this is the t half. What is meant by t half? T half is nothing but 0.693 upon lambda, or we can say it is as log 2 upon lambda, and this is given as 5,700. Okay, so we know the equation for n is equal to n naught e to the power minus lambda by lambda into t. We need this n after time 17,100. From here find out the lambda will be equal to log 2 upon 5,700. Cross multiply. Substitute the lambda over here. N naught, whether n naught is given or not. Okay, fraction is asked. Fraction means n upon n naught is asked. N upon n naught. So divide this n naught here. We get n upon n naught is equal to e to the power minus lambda t. This fraction is asked. So e to the power minus lambda. Lambda is how much? Log 2 upon 5,700 into time is 70,100. So this is nearly 3 times, exactly 3 times. So this is 1 term, this is 2 term. So we have e to the power minus 2 log 2. 3 log 2. This is n upon n naught. Now with the alpha rule, this minus 3 goes to the power of 2. So it will become n upon n naught will become e to the power log 2 to the power minus 3. This is nothing but e to the power log 1 upon 2 to the power 3 base e, which is nothing but e to the power log base e 1 upon 8. 2 to the power 3 is nothing but 8. Now this is the logarithmic identity, a number to the power log, and base of that log is the number itself. Then the answer will be index. So answer will be index, that is 1 upon 8. So this is your answer. N upon n naught is nothing but 1 upon 8. N upon n naught is nothing but 1 upon 8. So this is the question number 12. Question number 12. Now we'll solve question number 15. The energy released by the fission of 1 gram of uranium-235. 1 gram of uranium-235 in joules, given that the energy released per fission is 200 mega electronic volt. So per fission it released 200 mega electronic volt. Now per fission, that means how many number of atoms are there, we need to know. So number of atoms is equal to number of moles into Avogadro's number into atomicity. This atomicity is 1 for uranium. This is, you have studied this in 11th class, mole concept. Number of moles is mass upon molecular weight. Mass is 1 gram. Molecular weight 235. That is mass number. Avogadro's number 6.023 into 10 to the power 23. This is the Avogadro number. Now these are the number of atoms. If you multiply the number of atoms, so the total energy is equal to number of atoms multiplied by energy of one atom. So we'll get the answer. So calculate this. Multiply this answer with 200 megaelectron. We'll get the correct answer. If you want the answer in joule, this answer will get in. See, this answer 6.023 into 10 raised to power 23 upon 235 into 200 megaelectron. If you want this answer, this energy in joules, this electronic volt, replace this electronic volt by 1.6 into 10 raised to power minus 19. That is charge of electron. You will get the correct answer in joules. Okay. So this is question number 15. So this is the end of the exercise 1. Now we will start exercise 5. Let me refill the ink. So 5, exercise number 5, total 63 questions are there, out of which we are going to solve 4, 8, 12, 16, 20. 16 and 20 are multiple option correct questions, which are more than one correct. Then 24, 25, 26. 24, 25, 26. This is paragraph. After this, 29, 30 and 31. This is also paragraph. After that, we will solve integer type questions. 49, 52 and 59. 49, 42. 49, 52 and 59. So 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. So remaining 49 questions you have to solve. Remaining 49 questions you have to solve. So actually 1/4 म्हणजे 64 च्या 1/4 तर 16 येतात आणि म्हणून सॉल्व 14 बिकॉज काही मॅच द कॉलम आणि असर्शन रिझन वाले आहे जे खूप इझी आहे तुम्ही सॉल्व करू शकता बिकॉज assertion reason statement type questions need logical thinking and I don't want to spoil that questions to be the questions I don't want to spoil the curiosity ती curiosity जी असेल त्याला तुम्ही सॉल्व करा तुमचं तुम्हाला उत्सुकता असेल की कसे क्वेश्चन्स असतील वगैरे नाही आले तर तुम्ही मला विचारू शकता ओके नाउ क्वेश्चन नंबर 4 Question number 4. Two radioactive samples of different elements, half-lives given at T2. So, suppose the two materials A and B, half-life given at T2. This is T half. Okay, have same number of nuclei at T is equal to 0. So, at T is equal to 0, suppose it is having N0, this is also having N0. Same number of nuclei. The time after which their activities are same. So what is the time activities their activities are same? So first of all, we need to know what is the activity. So dn by dt is the activity, that is lambda n. This is the activity. Okay, and we need to know at what time these activities are same. So what is n? What is n? It is n naught e to the power minus lambda t. And the condition given is dn by dt for A is equal to dn by dt. This is the activity. For B, these two activities are same. That means lambda for A. ऐसा म्हणू शकतो आपण इथं. Lambda A n naught तर same है. Into e to the power minus lambda A into t is equal to lambda b n naught e to the power minus lambda b into t. N naught cancel. Now lambda we can calculate from times, half-life. We know half-life is log 2 upon lambda. Now this half-life is t1. T1 for lambda a. T1 for lambda a. So from here we can calculate lambda a, which is log 2 upon t1. Similarly, we can find lambda b, which is log 2 upon t2. This is 0.693. These are the values of lambda and lambda b. Okay. Now substitute these values here. What will we get? See, log 2 upon t1 e to the power minus log 2 upon t1 into t is equal to log 2 upon t2 e to the power minus log 2 upon t2 into t. Log 2 get cancelled. Okay. Now this t2 will come to this side. We will get t2 upon t1. So it will become t2 upon t1 is equal to this e to the power something in negative sign. When it goes to that side, it will be in denominator. हे जे आहे इथं न्यूमरेटर मध्ये खाली परत डिनॉमिनेटर मध्ये. जेव्हा ते डिनॉमिनेटर पासून परत न्यूमरेटर मध्ये जाईल, then it will become plus. So we'll get e to the power positive of this log 2 upon t1 into t minus of this log 2 upon t2 into t. Okay. Now from here, which are the terms we can take common are t upon t, log 2 and t. We can take common. Or we will do one thing. We can raise this t upon t1 to the power of this log, or just take log of both the sides. We will get log t2 by t1 is equal to log e to the power. From these two brackets, we can take log 2 and t common. It will be 1 by t1 minus 1 by t2 into log 2 into t. Now see, base is e, base is e. This whole is the power of e. This whole is power of e. That means it is the power of index. This is the power of index. That means this is alpha. We can remove this by alpha rule. So we get 1 upon t1 minus 1 upon t2 into log 2 into t into log e base e. Log e base e, which is nothing but 1. And it is equal to log t2 by t1 base e. Now it's very easy to find this t. हे t एका साइडला जाणार, बाकी साइडला तिकडे आहे. इथं होणार t2 minus t1. So t will be log t2 upon t1. t1 t2 क्रॉस मल्टीप्लाई केल्यानंतर log 2 खाली येणार. So T2 minus T1 upon log 2 आणि इथं T1 T2. So this is the answer. This is the answer question number 4. So very interesting question. Okay. So which option is correct? Option A is correct. Okay. A itself a correct answer. Now next question. Question number 8. Nuclei of radioactive element A are produced at a rate t square at any time t. Okay. The element A has a decay constant lambda. Let n be the number of nuclei at a time A. Okay. At time t is equal to t naught, dn by dt is minimum. The number of nuclei at time t is equal to t naught is. Okay. So see the rate dn by dt. This rate is given as t square minus lambda n. This rate is given as t square minus lambda n. Now when this rate is minimum, it is mentioned that this dn by dt is minimum at t is equal to t naught. Minimum कधी असते का फंक्शन मॅथमॅटिक्स मध्ये तुम्ही बघितलंय दिस इज मॅक्सिमम मिनिमम ऍप्लिकेशन ऑफ डिफरन्शिएशन. एनी फंक्शन इज मॅक्सिमम और मिनिमम व्हेन देयर फर्स्ट ऑर्डर डेरिव्हेटिव्ह और डिफरन्शिएशन इज 0. त्याचं जेव्हा डिफरन्शिएशन 0 असतं then we can say because slope is 0, tangent at that point is 0, so we can say it is either maximum or minimum. मग मॅक्सिमम किंवा मिनिमम असणार कोण मॅक्सिमम dn by dt म्हणजे त्याचा डिफरन्शिएशन आधी करायला पाहिजे. इथं बघा तुम्ही कन्फ्यूज होऊ नका, याला 0 पुट करू नका. ते 0 कधी पुट केलं असतं पण जेव्हा n मॅक्सिमम पाहिजे. इथं सांगितलंय dn by dt मिनिमम पाहिजे किंवा मॅक्सिमम पाहिजे, तर याचं डिफरन्शिएशन 0 आहे म्हणजे त्याचा स्लोप 0 पाहिजे. So we need to differentiate this. We'll get d square n upon dt square is equal to differentiation of this. It is 2t. Okay. Now lambda can be represented as lambda missing है यानी क्या मिलना है मुझे okay. Here this n is also not constant. What is the differentiation of n? That is dn by dt. This we need to equate it to 0. This whole term. कारण का हे function maximum or minimum we need this function, then its first order derivative. याचं first order म्हणजे n चं second order. हे already first order. So याचं differentiation 0 पाहिजे. So इथं dn by dt ची value substitute करूया. So we get 2t minus lambda. What is the value of dn by dt? It is t square minus lambda n is equal to 0. Open this bracket. And at this time, the time is t naught. So 2t naught minus lambda t naught square minus of minus plus lambda square into n is equal to 0. Now this is the quadratic equation between t and n. T naught and n. What is asked in this question? The number of nuclei of the element at. So n is asked. We need this n. For this n, take these two terms on right hand side. we'll get lambda square m is equal to lambda T naught square minus 2 T naught. Now divided by lambda, we'll get n. It is lambda T naught square minus 2 T naught upon lambda square. So this is the value of n at time is equal to T naught, where the rate or where the activity is minimum. Remember one thing, for maximize or minimize the function, its derivative should be 0. Function कोणतं maximum or minimum होता dm by dt, but त्याचा derivative 0, ते 0 नाही. पहिल्यांदाच ते मुळात स्वतः originally it is derivative of some n, ते स्वतःच एक derivative आहे, म्हणजे याचा अर्थ ते 0 नाही, त्याचं पुन्हा derivative करायला पाहिजे. ठीक आहे, तर ते function minimum or maximum. This is question number 8. Now next question, question number 12. A star initially has 10 raised to power 40 neutrons. So 10 raised to power 40 neutrons. Okay. It produces energy via the process. कोणती process आहे बघा? 1 hydrogen mass number 2 plus 1 hydrogen mass number 3 gives 1 hydrogen, that is tritium, plus proton plus 1 hydrogen mass number 2, that is deuterium, then again tritium gives helium with the emission of neutron. Now masses are also given. I will write here what are the masses. Before that, we will add these two equations. See, this tritium, which is on left hand side, will cancel out this tritium present at right hand side. Here the left hand side चा tritium आणि right hand side चा tritium एकमेकाला cancel करते. ठीक आहे. इथं आहे deuterium. Now किती झाले बघा या साइडला? एक deuterium, second वाला आणि हा third वाला. So total 3 deuteriums are there. On this side, 1 helium, 1 proton and 1 neutron. Okay. So this is the next total equation. What are the masses given? Mass of deuterium is 2.014 AMU. Mass of proton 1.007 AMU. Mass of neutron 1.008 AMU. Mass of helium is equal to 4.001 AMU. If the average power radiated by the star is 10 raised to power 16, the power radiated is of the order 10 raised to power 16. So power is equal to 10 raised to power 16. What is asked in the question? The time is the order of time चे order किती असतात सिस्टममध्ये? Power दिलेली. This is in watts. Power in watt is enough. Okay, watts मध्ये power given आहे म्हणजे SI units मध्ये आहे. And we know we want the order of time. Time चे order माहित पाहिजे. So we know students that power is equal to energy upon time. So time will be equal to energy upon power. Energy upon power. First of all, here there are 3 products, 1, 2, 3 and 1 reactant, or we can say 3 reactants, 3 deuteriums. So first we need to find the energy with the mass defect. What is the mass defect over here? Mass of helium plus mass of proton plus mass of neutron minus 3 times the mass of deuterium. So mass of deuterium will be 3 times this. Okay, so delta M will be equal to mass of helium plus mass of proton plus mass of neutron minus 3 times mass of deuterium. So this will be mass of helium 4.001 plus mass of proton 1.007 plus mass of neutron 1.008 minus 3 into 2.014. So it will be 6.015 minus 3 to the 6.042. So it will be 0.026. This is the mass defect. 0.026. 0.026. This is the mass defect. Now this energy is equal to delta M into C square. This energy will be in joules. Now this energy is for 1 deuteron. So we have to multiply it by 10 to the power 40. We will get the total energy for this many of deuterons. Okay. Upon power चे order दिए 10 to the power 16. Now here no need to divide it by 1.6 into 10 to the power minus 19 because we need the answer in watt. Power is in watt. So keep the numerator is in joules. Energy in joule. So delta M is 0.026 into C square 9 into 10 to the power 16 3 into 10 to the power 8 that is square into 10 to the power 40 upon 10 to the power 16. Okay, इथं काय विचारलंय पर मॉलिक्यूल विचारते का? So okay, don't worry, no problem. The 16 will cancel and 1, 2, 3 minus it from 10 to the power 40 will get 26 into 9 into 10 to the power 27. So this is the order of time we have. Now suppose if you want to the star exhaust during a time of order of. Okay. Okay, no problem. Order मध्ये convert करण्यासाठी what we need is this number should be between 0.5 to 5. Okay, 11th class मध्ये तुम्ही बघितलंय. In 11th class to find the order of any number, this number into 10 to the power any order from the R असेल. So if R is the order, then this number should be greater than 0.5 and less than 5. So convert this, first multiply 26 into 9, then take out the digits and make the number between 0.5 to 5 and मग हे order adjust करा. Okay, solve this, no problem. Now after this, question number 16. हा छान क्वेश्चन होता, लेंथी होता ना. पण कन्सेप्चुअल होता. रिएक्शन सॉल्व करता आली पाहिजे. याची मेन आणि प्रॅक्टिस तुमची केमिकल कायनेटिक्स मधून होऊन जाईल, केमिस्ट्री मधून. क्वेश्चन नंबर 16. For a certain radioactive substance, it is observed that after 4 hours, only 6.25 of the original sample is left undecayed. Okay. So after 4 hours, समजा initially N0 होते, तर finally किती राहिले 0.6.25% of N0. This is in 4 hours remaining. Okay. Now it follows that. Now first of all we will see what will be the half life and all the things. बघा गंमत बघा, this n is equal to n0 e to the power minus lambda t. Okay, what is n? N is, current n is 6.25% of n0. 6.25% of n0 म्हणजे 6.25 n0 upon 100 is equal to n0 into e to the power minus lambda t. n0 will get cancelled. Now 6.25 upon 100 we can write it as 625 upon 1, 2, 3, 4 is equal to e to the power lambda. Lambda can be written as log 2 upon t half. Log 2 upon t half. So we can replace this lambda as log 2 upon t half into t. 625. See, 25 25s are 25 4s are into 0 0. Again 25 ones are 25. 25 ones are 25, 15, 25 6s are 150, 16, 1 by 16. This 1 by 16 can be written as 1 by 2 to the power 4 is equal to e to the power minus log 2 into t upon t half. Now this 1 upon 2 to the power 4 can be written as 2 to the power minus 4. Minus 4, असा पण लिहू शकतो. Taking log on both the sides, we'll get log of 2 to the power minus 4 is equal to log of e to the power base e e to the power minus log 2 into t upon t half. Now this minus 4 and this the whole term, both are the power of index. Power of index is called alpha. We can remove the alpha. So minus 4 log 2 base e is equal to minus log 2 into t upon t half into log e base e. Minus minus cancel. Log 2 base e, log 2 base e cancel. Log e base e is 1. Now we are remaining with only 4 t upon t half. Now this t is given. This t is 4 hours. T is 4 hours. So 4 is equal to 4 upon t half. 4 4 cancel. From here t half is equal to 1 hour. T half is equal to 1 hour. What is asked in the question? Okay, this is more than one option correct. In this question, there are more than one options are correct. So first option, the half life of the sample is 1 hour. बरोबर है? Half life किती है? 1 hour. The mean life. What is the mean life? Mean life we know. mean life is, now half life is how much? 1 hour. From here, what is lambda? Lambda, first find out lambda. Lambda is equal to log 2 upon t half is equal to log 2 upon 1 hour. That means lambda is equal to log 2. Lambda is equal to log 2. What is the mean life? We are seeing mean life is equal to 1 upon lambda. Lambda is equal to 1 upon t. Mean life is equal to lambda 1 upon lambda. Reciprocal of lambda. So it will be 1 upon log 2. So option B is also correct. A is also correct. B is also correct. Then see option C. The decay constant of the sample is ln2. Decay constant is ln2. Yeah, it is also correct. Option C is also correct. Option D. After further 4 hours, the amount of the substance left over would by only 0.39%. Okay, that you calculate that what will be the final amount, taking this as n naught after further 4 hours. So we have to get this t as 8. Substituting 8 here or substitute 4, make the 4 substitute करें इधर 6.25 substitute करें. So find the final answer. The answer will be ABC. All answers are correct. Okay, exercise थोड़ा सा लेंगे है. Question number 20. Which of the following equations are possible? Now first equation for nuclear fusion विचारले. Nuclear fusion. Now option number D असा cancel होतो कारण that reaction is the splitting of uranium nucleus and that is not the fusion, that is the fission. So option D is नहीं. Okay, we need to check from option A, B and C. ए मध्ये एक मिस्टेक आहे, इथं 6 आहे, इथं 13 आहे, 1 1 आणि आन्सर मध्ये 6 आणि 14 आहे. 6 + 1 इथं 7 हवं होतं. दॅट्स व्हाय ऑप्शन ए इज इनकरेक्ट. ए आणि डी कॅन्सल. नाउ 50-50 झालं. ऑप्शन बी अँड सी आर करेक्ट. यू कॅन चेक, इट्स व्हेरी इझी क्वेश्चन. 6 + 1 is 7, 12 + 1 is 13. And 7 + 1 is 8 and 14 + 1 is 15. So option 20 मध्ये B आणि C correct असणार आहे. ठीक आहे. So we need to just check which is fusion reaction and correctly represent it. So option B is fission. तर ती अशी पण wrong आहे. Option A, B, C are fusion. But in the fusion A is not correctly balanced. Now question number 24, 25 and 26. That is a comprehension. When two radioactive nuclei A and B both converts into a stable nucleus C, nucleus A converts into C after emitting 2 alpha and 3 beta. एवढं केल्यानंतर C बनतो. ठीक है. 2 helium-4 plus 3 electrons एवढं बनल्यानंतर C मिळतो. आणि B कसा बनतो बघा. दिस इज क्वेश्चन नंबर 24, 25 आणि 26. पॅसेज आहे. B कसा इथे पार्टिकल 1 alpha particle, 1 alpha and 5 beta. So 1 alpha म्हणजे 1 2 helium-4 plus 5 beta. half life of A is now half life. Okay. Now initially A are 4 and not. So initial at t is equal to 0. At t is equal to 0, this is 4 and not, and this one is n not. A and B. Okay. Now half life t half life of A is 1 minute. 1 minute, and this is 2 minutes. Initially number of nuclei of C is 0. Okay, C is 0 है, so what? Take care, obviously that is the product. What is the question now? The first question, that is question number 24. If the atomic numbers and the mass number of A and B are Z1, Z2 and A1, A2 respectively. Z1, Z2, A1, A2 respectively, then which are like Z1, Z2, A1, A2 on the relation cancel. So question number 24 is that option A, Z1 minus Z2 is equal to 4. Option B, A1 minus A2 is equal to 4. Option C, both. Option D, none. This is question number 24. Now we need to find what is the difference between this Z1, Z2, Z2. Okay. All this. First of all, see, इधर Z1 है, इधर 2 2s are 4. 4 atomic number reduce झाला 4 न, आणि 3 न gain झाला minus. So 4 न reduce, 3 न gain म्हणजे 1 न reduce. So we can write this as Z1 minus 1. Balance होता है बघा. 2 2s are 4. 4 minus 3, 1, 1 minus 1, 0, Z1 is equal to 0. Now A1, mass number reduces by 4 to the 8. 3 into 0, no effect on mass number here. So 4 to the 8, mass number reduces by 8, so we can write A1 minus 8. Check the balance, minus 8, 2 4s are 8, 8 minus 8, 0, 3 into 0, 0, A1 is equal to 8. Now this is the balance. Now here Z2 atomic number reduces because of this variable by 2, Z2 minus 2, but gain by 5, that is 5 minus 2, 3. So Z2 plus 3. Check the balancing. 5 minus 1 minus 5. 3 plus 2 5. 5 minus 5 0. Z2 is equal to Z2. बराबर है? Now A2 atomic number decreases, mass number decreases by 4. No effect on the mass number, 5 to 0. So decreases by 4, that means it is A2 minus 4. Now गम्मत अशी आहे, हा जो C प्रोडक्ट आहे हा आणि हा सेमच आहे, त्यामुळे याचा atomic number आणि याचा atomic number सेम असणार, याचा mass number आणि याचा mass number सेम असणार. So we can write the two equations. Z1 minus 1 is equal to Z2 plus 3. This is the equation of atomic numbers. Because C is nothing but the same element. Z1 minus Z2. So bring Z2 here. It will be Z1 minus Z2 minus 1 तिकडे येणार plus 1. 1 plus 3 is 4. Option A is correct. Now equate these two. So A1 minus 8 is equal to A2 minus 4. So bring it here. A1 minus A2 is equal to minus 8 become plus 8. 8 minus 4. It will become plus 4. So A and B both are correct. So correct answer will be C. Both answers are correct. Both options are correct. Then next question, 25th question. What are the number of nuclei of C when number of A and B, number of nuclei of A and B are equal? So C च्या किती न्यूक्लिय बनलेले असतील जेव्हा A आणि B च्या न्यूक्लिय सेम असतील. So for that, we need to find the equation, that is n is equal to, for a से इनिशियल कितने हैं 4n naught, 4n naught, okay. Then e to the power minus half life is 1. What is the formula? What is the lambda? Half life, it is log 2 upon half life. It is lambda. Lambda a. So lambda will be equal to log 2 upon 1 minute. Lambda b will be equal to log 2 upon 2 minutes. These are lambda a and lambda b. So e to the power lambda a into t. So lambda a I will write log 2 into t. Now n for b. B से initial concentration क्या है? N0. E to the power minus lambda b log 2 upon 2 into t. If you divide these two, what will you get? N will cancel. 4n naught upon n naught is equal to multiplied by this divided by this. This is negative and here negative है तो खाली है, वरती वाला पॉजिटिव होना. It will become e to the power minus log 2 into t plus log 2 upon 2 into t. And cancel, and not cancel. So this will become this minus this, or this minus this with negative sign. So 1 is equal to 4 into e to the power minus log 2 upon 2 into t. ये minus है, particular denominator वाला वरती वाला positive होता. So we'll get e to the power log 2 upon 2 into t is equal to 4. Taking log of both the sides, it will become log 2 upon 2 into t log e base c is equal to log of 4. Log e base c becomes 1. Log e base c becomes 1. Now we get the time from here. This is log 4. We can write that log 4 as 2 to the power 2. Log 4 as 2 to the power 2. This 2 can be removed as power of index, that is alpha, which is 2 log 2. Log 2 will get cancelled. From here t is equal to 4 minutes. So now in 4 minutes the concentration of A and B will be same. In the 4 minutes the concentration of A and B will become same. What is that concentration? If you want to find that concentration, you have to substitute the value 4 here in the equation. You will get that concentration. So the number of nuclei will be, say, if I substitute n is equal to 4 here, what will you get? In any one of the equation you can substitute. Here I will substitute n is equal to n naught e to the power minus log 2 upon 2 into 4. 2 ones are 2, 2 to the 4. This 2 will go as alpha, so it will become, and this minus sign will also go, so it will become n naught e to the power 2 to the power minus 2. So it will become 2 to the power minus 2 is nothing but 1 upon 4. So it will become log 1 upon 4. Now this is the identity. E to the power log and base of that number, base of that log, that is e, the number itself. Then the answer is index. So answer will be n naught upon 4. This is n. So n is n naught upon 4. N is n naught upon 4. This is the remaining amount of B. I have substituted time is equal to 4 minutes in the amount of B. That means B is remaining n naught upon 4. B is remaining n naught upon 4. That means C is produced the same. कितनी produce होगा सर C? 3 n naught upon 4. 3 n naught upon 4. Okay. So from B, बघा ना एका n naught पासून n naught by 4 आता उरलेला आहे. So C produced is 3 n naught upon 4 from B. Now we need to find the what much of C produced due to A. A मुळे किती प्रोड्यूस झाला असेल. सो A मधला पण n0/4 A पण n0/4 उरला असेल. A इनिशियली किती होता 4n0. तो 4n0 मायनस n0/4 A पण इतकाच उरला असेल. पण तितका उरलेला काय कशात कन्वर्ट झाला असणार C मध्ये. सो 4 4 जा 16 16 minus 1 15 n0/4. This is the amount of C from A. This is the amount of C from B. Okay, 15 n0/4. 15 n0/4. So what is the total amount? 3 n0/4 and 15 n0/4. This is not. This is remaining of B. So 15 plus 2 3 18 n0/4. It will be 9 n0/2. Okay, 9 n0/2. Option number C, Chennai is correct. Very nice question. Most आत्तापर्यंत जेवढे क्वेश्चन सॉल्व केले त्यात खूप छान क्वेश्चन आहे हा. So 24 25 now 26. 9 n0/2 is the answer. At what time rate the disintegration of A and B are equal? So answer is 4 minutes. We have found out. So answer of 26. Okay, rate is same each other. Rate same. So for the rate, what we need to do is dn by dt same kara. We'll get the answer. dn by dt same kara. At what time the rate is same? So there we have to equate the dn by dt. What is dn by dt? It is lambda into n. Okay. So this is question number 24, 25 and 26. Very interesting question. I will see 29, 20, 30 and 31. Okay, 4 into 10 raised to power 23 tritium atoms are contained in a vessel. The half life is given, that is 12.3 years. Half life is given. Question number 29, 30 and 31. Half life is given. The half life T half is equal to 12.3 years. Okay. Find the activity of the sample. Activity which are there. Initial number of nuclei are also given. 4 into 10 raised to power 23. Okay. So from half life you can calculate lambda, that is log 2 upon T half, or you can say 0.693 upon T half. T half is 12.3 years. Now options are given in the seconds, so we have to convert this into seconds. So it will be 0.693 into 12.3. 1 year is 365 days. 1 day becomes 24 hours. 1 hour becomes 60 minutes. 1 minute becomes 60 seconds. So बघा या years ना आपण seconds मध्ये convert केले. 1 year 365 days. Days होता days. 1 day 24 hours. 1 hour 60 minutes. 60 minutes म्हणजे 60 seconds. 1 minute म्हणजे 60 seconds. So this is the lambda. Now काय विचारलं activity विचारले. Activity. So as this is lambda, we know what is the activity. dn by dt, which is nothing but lambda into n. You have lambda, you have n. Find out the activity. Calculate करा. खूप जास्त calculations आहे. Substitute the value of lambda as well as n. You will get activity. फाइंड द नंबर ऑफ डिकेज इन द नेक्स्ट 10 आवर्स. 10 आवर्स मध्ये किती होणार करू शकता तुम्ही. n is equal to n naught you have into e to the power minus lambda. लॅम्बडा ची एवढी मोठी व्हॅल्यू आहे ती इथे पुट करायची into t. t किती सांगितलंय 10 आवर्स. सो e you know लॅम्बडा ची व्हॅल्यू माहिती आहे n naught माहिती आहे n naught lambda t आणि e is a constant. So each value किती आहे 2.3. सगळ्या व्हॅल्यू पुट करा you get 10. So this is question number 30. Question number 31 same as है. Find number of decays in 6.5 years. So n is equal to n naught e minus lambda into t. This t is 6.15 years. So you should write this lambda in years. No need to write all the things. Just 0.693 into 12.3. Substitute this lambda here and not you have here. Will get it. So this is 28, 29, 30. हे तीन सॉल्व करून मला तुम्ही दाखवा. सिंपल क्वेश्चन्स आहेत फक्त कॅल्क्युलेशन जास्त आहे. लॉजिक मी तुम्हाला सांगितलं. Now question number 49. At a given instant there are 25% undecayed radioactive materials. 25% आहे. 8 सेकंड मध्ये 8 सेकंदामध्ये ते किती झाले 12.5% झाले 8 सेकंदामध्ये. खूप छान लॉजिकल क्वेश्चन आहे. मुलं बघून क्वेश्चन सोडतात की इतका डिफिकल्ट क्वेश्चन आहे कसं करायचं काय करायचं. Question number 49. See, initially there were 25% of nuclei. This converts to 12.5% in 8 minutes. बघा 25 च्या हे अर्ध आहे म्हणजे अर्ध वेळा 8 मिनिट लागले म्हणजे 1 मिनिट इज हाफ लाईफ. आणि आता असं विचारलंय 6.25 व्हायला किती मिनिट लागतील म्हणजे याच्या अर्ध व्हायला आणखी 8 मिनिट लागतील. विषय सिंपल व्हेरी सिंपल क्वेश्चन. ठीक आहे कारण का हाफ लाईफ त्यांनी सांगितले 25 to 12.5 ला 8 मिनिट्स. मग आपण समजून घ्यायचं ही हाफ लाईफ गिवन आहे आणि आता 12.5 चा 6.25 आहे म्हणजे ह्याच्यापेक्षा आणखी हाफ व्हायला किती वेळ लागेल तर अगेन 8 मिनिट्स. सो व्हेरी सिंपल लॉजिकल क्वेश्चन. नो नीड टू सॉल्व दिस क्वेश्चन. सॉल्व करायची गरज नाही तिथेच अडकून ठेवू नका. दिस इज न्यूमेरिकल टाइप क्वेश्चन. सो नो ऑप्शन्स आर गिवन. इंटिजर टाइप क्वेश्चन. द रेडियोएक्टिविटी ऑफ अ सॅम्पल R1 at time t1. R1 आहे रेडियोएक्टिविटी at time t1 that means this is dN by dt is R1 at time t1. Okay, then R2 at time t2. This dN by dt is R2 at time t2. If the half life of the specimen is t, so t half is equal to t. T half is given, that is t. The number of atoms that have disintegrated in the time t2 minus t1. t2 minus t1 मध्ये जेवढा disintegrated झालेला आहे म्हणजे n2 minus n1. This is given n into r1 minus r2 into t upon nl4. Then you have asked the value of n. What is this n? What is this n? Integer type question. You have asked the value of n. Okay. Now see, dear students, we know what we know is what is this R1? This is activity and which is nothing but lambda into n. Lambda into n. For t1, so I will write n1. This will be lambda into n2. Lambda into n2. From here we can find what is n1. So n1 will be equal to r1 upon lambda. From here n2 will be equal to r2 upon lambda. If I subtract these two, we'll get n2 minus n1 is equal to r2 upon lambda minus r1 upon lambda. Okay, so r1 minus r2 r1 minus r2 are the same thing. Okay, so 1 minus 2 आहे त्याला opposite केला तर 2 minus 1 घेतो मी, तर 2 minus 1. Lambda is common. What is lambda? Half-life. Half-life is t. We know what is half-life. It is log 2 upon lambda. Half-life is given t, which is log 2 upon lambda. Lambda is equal to log 2 upon t. Substitute this value here. We'll get r2 minus r1 upon log 2 upon t. Log 2 upon t. At t वरती ना, we'll get r2 minus r1 into t upon log 2. Upon log 2. आता या आन्सर मध्ये आणि या आन्सर मध्ये काय काय फरक आहे? r2 minus r1 आहे, r2 minus r1 आहे. t आहे, t आहे. इथं log 4 आहे, इथं log 2 आहे. Now to write log 4 here, I will write 2 here and 2 here. I will divide and multiply and divide it by 2. Now see, when this 2 goes here as the power of index, it will become alpha. So it will be 2 r2 minus r1 into t upon log 4. Now this is same as the given answer. This is same as the given answer. Hence n is equal to 2. Hence n is equal to 2. So answer of this question is 2. Integer type question. So this is question number 52. And the last question you can solve yourself. Calculations same as the first question of first level, I think. All the classes are given. You have to find delta m. Okay. n4 plus alpha n14 plus alpha gives oxygen 17 plus proton. Mass of n14 is given 14.00374. Mass of helium 4 is also given. Mass of proton is also given. Mass of helium is also alpha particle. Mass of oxygen 17 is also given. These masses are given. You have to find the energy. So again the same question. So many calculations are there. Delta M you have to find. Product. Mass of product minus mass of reactant, that is delta M. Delta M into C square upon 1.6 into 10 to the power minus 90. Find the binding energy of this. There X is present and we have to find the value of X. Okay. So hope you are studying well. Complete level 1 and level 5. In next lecture I will discuss level 2 and level 6. Okay. Thank you very much.